Hi there, guys. It's Mr. Zanoni, and today we're going to be talking about volume of cylinders, cones, and spheres. So recall that the formula is volume equals the area of the base times the height of the prism. For a cylinder, that B, base, is the area or the area of the circle. B equals pi times radius squared. So volume equals area of the base times the height. So pi r squared times the height of the cylinder. Area of the circle is pi r squared times the height of the cylinder. Because this is how wide the bottom is, and if I fill it up, I'd have to be able to push this circle all the way up to the other circle. Okay. So the volume of a cylinder is pi times radius squared times the height. Okay. All right. In this example, we're going to find the volume of the cylinder, and we're going to round to the nearest tenth. So I have the diameter is 14 centimeters because it goes from one side of the circle through the radius to the other side, through the center to the other side of the circle, and I have the height. Well, the area formula needs radius, so I need to do 14 divided by 2 to get 7, so the radius is 7. So volume equals pi times 7 squared times 20. Volume equals 49 times 20 times pi. I'm going to multiply everything that is not pi first. 49 times 20 is 980. We're going to use pi equals 3.14 in this problem, so 980 times 3.14 gets me 3,077.2 cubic centimeters. Because we did centimeters times centimeters times centimeters. That's why it's centimeters cubed or cubic centimeters. And this is I know it's hard to see, but this is a 3. You'll have the notes with you, but this is a 3 right here. Okay? All right. Find the volume of the cone. Round to the nearest tenth. So if I look at this, I can put a cone inside of a cylinder. And when I do this, you can kind of see, if I did this, I have 1, 2, 3 triangles. If you look at this cone, I only fill one of them. So I'll still use the pi r squared h from the cylinder formula, except for I'm going to have to divide it by 3 or multiply it by 1/3. So the volume of a cone is 1/3 times pi times radius squared times height. 1/3 pi times 5 squared times 7. Order of operations says I got to do exponents first, so 5 squared is 25. Now I'm going to multiply 25 times 7, get 175. I'm going to rewrite 1/3, and 175 is 175 divided by 3 as a fraction times pi over 1. I'm going to plug all this into the calculator, making pi 3.14. When I do that, I get 182.88 millimeters cubed or cubic millimeters. Again, this is a 3 here because I did millimeters times milliliters, millimeters times millimeters times millimeters. Okay. Now let's go over the last one, volume of a sphere. Okay. Volume equals area of the base times the height, so pi r squared h. The height of a sphere is 2 radiuses, so this is 2 radius, so I have 2 pi r cubed. However, the sphere only fills up 2/3 of the cylinder, so now I have to do 2/3 times 2 times pi r squared, which becomes 2/3 times 2 is 4/3. So it becomes 4/3 times pi r cubed. So 4/3 pi r cubed is the volume formula. All right, now that we have the formula, now we're going to talk about how to find the volume of a sphere. We're going to round to the nearest tenth here, okay? In the homework and other practice problems, I might have you round to the nearest hundredth, which would be 2 decimal places, okay? So we're going to start by writing the area formula. Next, I'm going to plug in 8 for the radius. So I substitute r with 8. Then I do 8 cubed because of PEMDAS, which is 512. Then I do 4/3 times 512, which is 2048 over 3 times pi over 1. I'm going to plug all this in the calculator at the same time, making pi 3.14. When I do that, I get 2,143.6 inches cubed. If I was doing nearest hundredths, it'd be 0.57, okay, inches cubed. But because I said tenth in this case, that's why I rounded to 0.6. All right, we got to go over one more problem. I want to find the volume of the composite solid to the right. I have a cone, a cylinder in the middle, and then a cone on the bottom. So I need to find the volume of the cone plus the volume of the cone plus the volume of the cylinder to find the volume of the entire thing. So 1/3 pi r squared h, 1/3 pi r squared h, and pi r squared h. These are the volume formulas for a cone, and cylinder. I need to use those. Now I'm going to substitute in the radius and the height. So the radius of the cone, so we know the diameter is 11 for the cone and the cylinder. So 11 divided by 2 is 5.5 to get me the radius. So the radius is 5.5 squared. The height of the cone, that's a little trickier to do, but I know from here to here is 2. And I know from this point to this point is 10. 10 minus 2 is 8. And they are the same size. So this 8 divided by 2 is 4. So this to this has to be 4. And this to this has to be 4. So that's how I know that this height is 4 and this height is 4 for each of the cones. So these are actually going to have the same volume formula. And then this one I'm going to multiply by 2. Then when I go through, I follow PEMDAS and do 5.5 squared. That gets me 30.25. And then I'm going to go through and do 4 times 30.25 is 121 over 3 pi. Do the same thing here. And then 30.25 times 2 is 60.5. Then when I plug then what I'm going to do is I can technically add these together. If I factored out pi, I could do 121 over 3 plus 121 over 3, which is 242 over 3 pi. Then, well, and then I apparently changed this to 80 and 2/3 pi, which I didn't really need to do. I could just do 242 over 3 times 3.14. Oh, I see why I did that. I changed this so they would have I made it so these were both mixed numbers, so I would have could turn them both into mixed numbers. Okay, so I changed this to 60.5. I just changed this into 80 2/3. And then when you add these together, you get 141. I just gave them a common denominator. So this became 4/6. This became 3/6. When you combine them together, you get 141 and 1/6 pi. Now I would take this lovely thing, which is 847 over 6 times 3.14. And I would end up 847 times 3.14 divided by 6, and I get 443.26. If I was rounding to the nearest hundredth, I would leave it as a 6, but my directions, again, in this case, said round to the nearest tenth, so I made it 0.3. 443.3 centimeters cubed. All right, now it is your turn to try out the following problems. Okay. All right, so we need to use the volume formula. Volume equals pi r squared h. The radius is 3. The height is 12. 3 squared is 9. I get 108 pi. And then I'm going to have to, on a calculator, do 108 times 3.14. And you would get 339.12, but we're rounding to the nearest tenth, so 339.1 inches cubed is the volume. All right, volume equals, it's a cone, so 1/3 pi r squared h. 1/3 pi, the diameter is 7, so the radius is 3.5, squared times 9. 3.5 squared is 12.25. We need to multiply 9, pi, and 1/3. I'm going to do 12.25 times 9, and I get 110.25 over 3 times pi I'm going to do that in my calculator. It's just going to take me a moment. And I get 115.395. I round that to the nearest tenth, and I get 115.4 inches cubed. Even if it was actually, the interesting thing here is if it was nearest hundredth, they'd be the same answer. So I just add a 0. All right, now let's find the volume of this sphere. This is a diameter of 10, so I know the radius is 5. So volume equals 4/3 pi r, you want to say it's cubed. Yep, cubed is the formula. See? It's very important you know the formulas. It's because I've been saying pi r squared so much. Anyway, 5 cubed. First thing I do is 5 cubed. Which is 125, so 4/3 times pi times 125. Now I'm going to multiply that by 4. So I have 500 over 3 times pi which we're going to use 3.14, and I get 523.333 repeating, ... Nearest tenth says 523.3 centimeters cubed. Okay. And finally, the volume of a cylinder is 618 meters cubed. Find the height of the cylinder. So 618 equals pi r squared, so 4 squared h. 618 equals 16 pi h. To solve for h, I would divide both sides by 16 pi. Okay, so 16 times 3.14, that's really 50.24. So this is really what's going on here, is 618 divided by 50.24 equals h. 618 divided by 50.24, that's not what I wanted, 0.24, thank you. And I get h equals 12.30, and another 0 and a bunch of stuff, but I said nearest tenth, so it's 12.3 meters is the height. Okay, and I would write that as a sentence. I'd write all these as a sentence. And that's it. Thank you for watching. It's Mr. Zanoni. We're going to be going over a volume of a composite solid. Okay, so I have 2 rectangular prisms and a cylinder. So the volume of the composite solid, I'll use CS for composite solid, is the volume of the cylinder plus the volume of the rectangular prism plus the volume of the rectangular prism. Okay, so I have pi r squared h plus base times height plus base times height. Okay, the radius of my cylinder is 1 divided by 2, which is 0.5 squared. The height of my cylinder is 3.5. The area okay, define the area of my base. We're going to say it's 1.5 times 1.5 times 0.5, and there's 2 of them, so I'm going to just do that again over here, because this and the bottom, let's say the bottom rectangle is our base, is 1.5 times 1.5 times the height would be 0.5. Rectangular prisms are annoying to deal with volume and surface area because their base isn't always the easiest. You can pick and choose, so it's not consistent. So I'm going to multiply in the calculator these numbers. So this is 1.125, which means this guy is going to be the same. It's the same numbers. And now I'm going to deal with this one. So 0.5 times 0.5 is 0.25 times 3.5 gets me, 0.875 pi. I'm going to multiply that by 3.14. I get 2.7475, and I'm going to add these two together while I can, just to make 2.25, and then I'll combine that with 2.7475. I get 4.9975, and no matter what I round to, whether it's rounded to nearest tenth or nearest hundredth, I would get 5.0 or 5.00 feet cubed. The volume of the composite solid is 5 cubic feet, would be my answer. And that's it. Thanks for watching.